Under the vast expanse of the celestial sphere, a huge scarlet star in the middle of the most visible and simple-to-identify stellar bodies asserts its dominance, far beyond the horizon. Our complete comprehension of this vast cosmic entity possesses the capability of releasing a magnitude of energy that could rival an individual's combined radiance. An innumerable array of stars, this astronomical giant, possibly on the verge of a catastrophe, may soon experience an event, a burst of such magnitude that it could surpass 1 billion suns. The real question is, are we prepared for the aftermath such an event could bring? This massive red star, commonly referred to as Goliath, is in close proximity to Earth and has emerged as the focus of significant fascination and debate in the scientific community, as well as the general public. In recent times, this star underwent significant transformation, raising more and more concerns among researchers and fueling intense discussions regarding its future trajectory. The most frightening possibility is that this change may indicate the explosive early stages of a supernova, a dazzling event that marks the final phase in a star's life cycle. This is scientifically known as Orion. If the star ran out of nuclear fuel, it might collapse under its own gravitational pull, triggering a catastrophic explosion. Not only does such an event cause anxiety among scientists, but also for those of us on Earth. The potential repercussions could be extraordinary. Alpha Orion can be easily identified by its deep crimson hue and is referred to as the brightest and largest star in the Orion constellation. With the aid of advanced tools such as NASA's Hubble Space Telescope, astronomers have closely observed its behavior, specifically in 2019, when it suffered a significant loss of mass, a phenomenon considered rare for stars of this type, raising alarms across the scientific community. While our Sun frequently goes through coronal mass ejections, the unusual event seen in Alpha Orionis has sparked a re-evaluation of what occurs during the last few years of a massive star's life. Scientists are currently divided over the precise distance of Alpha Orionis. Estimates from Earth differ, with some placing it as far as 1,200 light-years away, while others suggest it might be as close as 724 light-years away. The difficulty in determining the exact position of stars like Alpha Orion lies in the immense distances involved and the atypical characteristics of red giants. Despite concerns regarding its accuracy, the place where Alpha Orionis resides continues to captivate observers. Magnificent stars in the night sky shine multiple times as brightly as our Sun, but this luminous glow comes at a significant cost. Alpha Orionis is consuming its nuclear fuel at a rapid pace, which accelerates its journey toward the inevitable end of its life cycle. After it runs out of fuel, the star's supply will likely fail, conceivably forming a neutron star or, in a more catastrophic scenario, a black hole, depending on the manner in which the explosion unfolds. This leads to a pressing concern. Could Alpha Orionis pose a threat to Earth should a supernova occur within a few light-years of our planet? The ramifications would be destructive. A supernova can produce an unimaginable amount of energy, potentially outshining entire galaxies, which presents the possibility of far-reaching consequences, even if Alpha Orionis lies at a considerable distance from our planet. Historically, the last supernova event that was recorded in our galaxy took place in the year 1604. Since then, humanity has not witnessed a similar occurrence. On a local scale, however, a significant event occurred in 1987 when a supernova exploded in the Large Magellanic Cloud. Despite the fact that this is 169,000 light-years away, the explosion had notable consequences for its immediate environment but posed no direct threat to Earth. Nonetheless, these rare occurrences are potent reminders of the immense scale of supernova explosions and the dangers they may present. A supernova, particularly one occurring close to Earth, could create what is known as a danger zone due to the threat it poses to life on Earth. However, this should be viewed in the broader context of cosmic events. While supernovae are infrequent gamma-ray bursts, GRBs, represent an even more serious threat. These bursts are capable of destroying entire planetary biospheres and flooding them with deadly radiation. For instance, GRBs have the potential to destroy a planet's ozone layer, making it accessible to harmful ultraviolet radiation from its sun, effects that could persist long after the burst itself has subsided. The looming threat of GRBs has become a focus of recent research, shedding new light on the potential hazards associated with stellar explosions that culminate in such dramatic and destructive events. When massive stars explode as supernovae, their brightness can be greater than entire galaxies. This intensity raises an important inquiry. What would occur if Alpha Orionis were to undergo a similar transformation? If it bursts into flames as a supernova, it could become the second brightest object in the sky, second only to the Sun in terms of visibility, even though the energy released in such a blast could be so intense that it might even be visible during daylight hours. This blinding spectacle would illuminate the middle of the day, offering an unnerving experience for those witnessing it. The real threat lies in the high-energy radiation accompanying such an explosion. This radiation, typically in the form of X-rays and gamma rays, would have far-reaching consequences. One of the most pressing concerns is that it could deplete Earth's protective ozone layer. Without the ozone layer, Earth would be subjected to dangerous levels of potentially harmful ultraviolet light, leading to extinction events. The dangers posed by a supernova do not cease immediately following the explosion. Remnants from the explosion, such as shock waves traveling at nearly the speed of light, would remain a threat as they spread throughout the solar system. These shock waves could further damage the ozone layer, subjecting Earth to an even greater risk of harmful radiation, which would only increase the risks over time. In addition, the long-term effects of a supernova's energy release could linger for centuries, leaving lasting damage. Some interesting studies on the planet indicate that Earth may already have been affected by the aftermath of a supernova in the past. Elevated levels of iron-60, an isotope of radioactivity created in supernova explosions, have been observed in deep-sea sediments and lunar soil, indicating that Earth has likely encountered the fallout from such an occurrence in its geological past, possibly within the last few million years. There are currently no known candidates for supernovae close to Earth that pose an immediate threat. However, ongoing research is continuously uncovering new threats, particularly those coming from long-range, radiation-emitting supernovae. When a star nearing the end of its life is enclosed by a huge disk of material, and the shock waves from the explosion interact with this material, powerful X-ray radiation is produced that can traverse space and travel great distances. This radiation has the potential to impact planets within a 150 light-year radius. Thankfully, no such candidates have been identified in our vicinity, but new perspectives have been gained from this study. The materials produced by a supernova explosion serve as the building blocks for the next generation of stars and planetary systems. These elements, forged under the extreme pressures and temperatures within the core of a dying star, are crucial for the formation of rocky planets like Earth. Without the heavy elements produced by these cosmic explosions, the conditions necessary for life as we know it would be impossible. In this way, supernovae play a critical role in the cycle of stellar evolution, shaping the very environment in which life can emerge. The destruction of a star leads to the creation of new stars and, ultimately, new planets. This process highlights the dynamic and ever-changing nature of the universe. The death of one star paves the way for the birth of others, and the remnants of these violent explosions continue to enrich the interstellar medium with the elements required for the formation of new worlds. As we look deeper into the universe, the study of supernova remnants not only helps us understand the life cycle of stars, but also provides insights into the larger-scale structure of the cosmos. By observing how stars evolve and explode, astronomers are able to map the cosmic web, the vast network of galaxies and clusters that stretches across the universe. This knowledge is essential for understanding the expansion of the universe itself and the forces that drive its evolution. Moreover, the study of supernovae and their remnants has led to breakthroughs in cosmology, particularly in our understanding of dark matter and dark energy. By observing the behavior of supernovae in distant galaxies, scientists have been able to infer the presence of these mysterious substances that make up the majority of the universe's mass and energy. The energy released during a supernova explosion, as well as the way it affects the surrounding space, can offer valuable clues about the nature of dark matter and the accelerating expansion of the universe. The death of a star may seem like the end of its story, but in the grander scheme of the universe, it marks the beginning of something new. Each supernova explosion carries with it a wealth of information, providing us with a deeper understanding of the universe's origins, its current state, and its future. These cosmic events remind us that everything in the universe, from the tiniest particles to the largest galaxies, is interconnected in a vast and intricate web of life, death, and rebirth. As we continue to explore the mysteries of the cosmos, we must acknowledge the delicate balance between creation and destruction. While supernovae and other cosmic events can bring about dramatic changes, they also contribute to the ongoing evolution of the universe, creating the conditions necessary for life to thrive. By studying these processes, we not only gain a better understanding of the universe's past and present, but also prepare ourselves for the challenges and wonders that lie ahead. In the end, the universe is a constantly changing and evolving entity, where the deaths of stars give rise to the birth of new ones, and the cycle of life and death continues. As we continue to look toward the stars, we are reminded of our place in this vast cosmic dance, where each new discovery brings us closer to understanding the universe and our role within it. Whether we face the threat of a supernova or the promise of new life, the universe remains a place of awe and wonder, where each moment brings with it the potential for new insights and revelations. These are hefty components of the solar system, and even our sun's existence would be impossible. Supernovae, therefore, are not merely destructive events. They also play a vital role in the development of the very components that make up the stars and planets we observe today. Furthermore, the study of supernovae has deepened our understanding of observing the universe's expansion. The brightness of supernovae of type Ia, caused by a white dwarf's explosion in a binary system, allows astronomers to use it to measure cosmic distances with extraordinary accuracy. These standard candles have revolutionized our ability to map the universe by supplying essential information about dark energy. Despite the rapid expansion of space and the substantial advancements in our ability to measure cosmic distances, the potential dangers posed by supernovae cannot be overlooked. Although the possibility of a nearby supernova affecting Earth remains low, the long-term consequences of such an event may be significant. Earlier, we mentioned the powerful radiation released by a supernova that could disrupt the solar system's environment. This radiation could interact with Earth's atmosphere, exposing and depleting the ozone layer, allowing harmful UV radiation from the sun to reach the surface. Without the ozone layer, survival on Earth could become increasingly challenging, if not impossible. Additionally, the shock waves from a nearby supernova could disrupt the structure of the solar system. These waves would compress the interstellar medium, potentially starting the formation of new stars or altering the orbits of objects within the solar system. In the worst-case scenario, a nearby supernova could disturb the delicate balance of the solar system, leading to catastrophic changes in planetary orbits and possibly even posing a threat to Earth's existence. The study of supernovae and their relics raises intriguing questions regarding the future of the universe. As stars die and supernovae occur, their ashes can eventually produce neutron stars or black holes, some of the most enigmatic and extreme objects in the cosmos. Black holes, in particular, are regions of space where gravity is so intense that not even light can escape. These objects are thought to be the last stage for the most massive stars, and their formation is one of the most fascinating occurrences in modern astrophysics. Despite their destructive nature, supernovae are integral to the ongoing evolution of the universe. The materials they release into space serve as the building blocks for the development of new stars and planetary systems. As new stars are created, the stellar cycle of life and death continues to drive the development of galaxies, contributing to the universe's ever-expanding nature. In conclusion, while the potential threat of a supernova explosion is still far off and not a major concern for Earth, the study of these events is necessary for progressing our understanding of the universe. Supernovae not only provide valuable insights into the life cycles of stars, but they also offer important information about the chemical makeup of the universe and the ways in which galaxies evolve over time. As we continue exploring the vast reaches of space, our understanding of these extraordinary cosmic events will enhance, providing a clearer and more comprehensive view of the universe. As we proceed, the past, present, and future of our exploration of the universe make it clear that studying these immense cosmic phenomena, like supernovae, will continue to reveal new layers of understanding about the universe and its intricate mechanisms. Each step in this understanding is made easier by research. The true scope of how stars live, die, and contribute to the dynamic, ever-evolving universe around us is becoming clearer. Supernovae and their consequences, like neutron stars and black holes, represent some of the most fascinating and mysterious aspects of astronomy. These phenomena bring up profound concerns regarding the ultimate fate of stars and their role in the larger cosmic framework. The processes that lead to a supernova explosion involve extremely complex nuclear physics, and yet the resulting impacts stretch across vast distances, influencing the evolution of entire galaxies, the birth of new stars, and enriching the cosmos with essential heavy elements. Understanding how these events unfold and the conditions that trigger such explosive events helps scientists piece together the puzzle of stellar evolution. In addition to the critical role they play in star formation and the creation of elements, supernovae serve as a critical instrument for determining cosmic distances. By analyzing the light from these dramatic stellar explosions, astronomers can create more accurate maps of our universe, following the growth of space and the distribution of galaxies across vast distances. These measurements are essential in determining the age, scale, and structure of the universe, and they have led to groundbreaking discoveries regarding the mysterious force known as dark energy, which appears to be accelerating the expansion of the cosmos. This precise ability to measure distances using supernovae has had ripple effects on all aspects of astrophysics, providing more detailed and reliable methods for gauging distances across the universe. We have gained a deeper comprehension of the speed at which the universe is expanding and how galaxies are evolving. The presence of dark energy, first inferred through observations of distant supernovae, has reshaped our understanding of the universe's future, implying that the universe is not just expanding at a steady rate, but the rate is accelerating. Despite the incredible knowledge gained from these supernova studies, the potential risks from a nearby supernova explosion remain a fundamental concern. While such an event is unlikely in the immediate future, the possibility, however remote, demands our attention. The negative consequences that come with supernovae, particularly the radiation and the shock waves they produce, may have significant effects on planets in the vicinity. If Earth fell within the range of such an event, the consequences would likely result in disaster, from the destruction of the ozone layer to the disruption of the solar system's delicate balance. Understanding these risks requires scientists to reflect deeply on how life on Earth could be affected by cosmic events. If the ozone layer were depleted from radiation released by a supernova, Earth's atmosphere would no longer protect people from harmful solar radiation. The planet could be bombarded with deadly ultraviolet rays, leading to widespread environmental and biological harm. This threat to life, as we know it today, makes it essential for researchers to continue their studies into the effects of supernovae and other cosmic hazards. Interestingly, some scientists propose that Earth may have experienced similar catastrophic events in its early history. Evidence from isotopes found in ancient geological deposits suggests that Earth has encountered the remnants of past supernovae. This suggests that supernova explosions are more than just theoretical risks. They are events that may have had a tangible impact on the history of our planet. Whether such past supernovae played a role in shaping life on Earth or caused mass extinctions is still a subject of controversy. But the possibility that these cosmic explosions have contributed to our planet's history adds an additional layer of mystery to the study of supernovae. The potential for gamma-ray bursts, GRBs, to devastate planets highlights the importance of understanding these cosmic events. While they are extremely rare, their destructive power is unparalleled. A GRB could strip away the atmosphere of a planet, exposing its surface to intense radiation and potentially making it uninhabitable. The implications of such an event, though hypothetical, are significant, and researchers are keen to understand the conditions under which GRBs occur and their potential impact on life. The study of GRBs is still in its early stages, and much remains to be learned about the mechanics of these explosions. The energy released in a GRB is believed to be associated with the collapse of massive stars or the merger of compact objects like neutron stars. These events release a concentrated burst of gamma rays, which travel across vast distances in space. If a GRB were to occur within our galaxy, and if its beam were directed at Earth, the consequences could be catastrophic. The radiation from the burst would likely disrupt the atmosphere, possibly stripping away large portions of the ozone layer, thereby allowing harmful ultraviolet radiation from the sun to reach the surface. While such an event is statistically unlikely, the possibility cannot be dismissed entirely. The study of GRBs, along with other extreme cosmic phenomena like supernovae, neutron stars, and black holes, is crucial for understanding the broader cosmic environment in which Earth exists. By gaining a better understanding of these events, astronomers can not only improve our knowledge of the universe, but also enhance our ability to predict and mitigate potential threats to life on Earth. In addition to their potential destructive power, gamma-ray bursts and supernovae play a critical role in the ongoing process of stellar and galactic evolution. The energy and material released by these explosions contribute to the formation of new stars and planets, enriching the interstellar medium with heavy elements that are essential for the development of life. In this sense, supernovae and GRBs are both destructive and creative forces, shaping the universe in profound and often paradoxical ways. As technology continues to advance, astronomers are developing more sophisticated tools to observe and study these extreme cosmic events. Telescopes capable of detecting high-energy radiation, such as gamma rays, are allowing researchers to observe GRBs and supernovae in greater detail than ever before. These observations provide critical insights into the life cycles of stars, the evolution of galaxies, and the forces that shape the cosmos. The study of supernovae, GRBs, and other cosmic phenomena also contributes to our understanding of the larger, more enigmatic questions about the universe. For instance, the role of dark energy in the acceleration of the universe's expansion is still not fully understood. Supernovae, particularly those of type Ia, have been instrumental in revealing the presence of dark energy, but many questions remain about its origin and nature. Is it a form of energy inherent to the fabric of space itself, or does it arise from an unknown source? How will dark energy influence the ultimate fate of the universe? In conclusion, while the catastrophic potential of supernovae and gamma-ray bursts is a real concern, the study of these cosmic phenomena also provides invaluable knowledge about the universe's structure, history, and future. By examining the life cycles of stars, the forces that drive galactic evolution, and the impact of extreme events on planetary systems, we can gain a deeper understanding of the cosmos and the forces that shape it. Though the risks associated with these events may be low, their study is crucial for our ongoing exploration of the universe and our ability to predict and respond to cosmic events that could affect life on Earth. As we continue to explore the vastness of space, we are likely to uncover even more mysteries related to the life and death of stars, the birth of new galaxies, and the evolution of the universe itself. The study of supernovae, gamma-ray bursts, and other cosmic phenomena will remain a key area of research, offering new insights into the forces that govern the universe and the role that our planet plays within it.